Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at the study guide. Hopefully you've worked through all these problems and are ready for the test, but let's just take a look at it and make sure that you're getting everything correct. Remember, when you have a right triangle, Pythagorean theorem says that a squared, call this side A, plus b squared, call that side B, will be equal to c squared. Now in this case, we're calling this side X. Same basic idea. This is side C, the hypotenuse of the right triangle. So you take the sum of their squares and add them together, and you're going to get a number that when you find the square root of that number, that will tell you the length of side C. So in this case, this side, it doesn't really matter which one is A and B. Remember, we've said that a few times, but 10 squared is 100. 5 squared is 25. Add them together, you get 125. The square root of 125 is going to be a little bit more than 11. Remember when we were estimating square roots, how 121 is 11 squared, so the square root of 121 would be 11, and this is a little bit more than 121, so it's going to be a little bit more than 11. Of course, just use your calculator. It's so easy to just take 125 and find the square root button, and there you go, and choose to round it to the nearest tenth, to the nearest hundredth. I wouldn't go into the thousands. So you could call that 11.2 centimeters or 11.18. So the key is when you're looking through these problems to identify which side you are missing. So they will give you two side lengths, and you determine whether or not those are the legs or if one of those side lengths is the hypotenuse. So they're both the legs, they form the right angle, so they're the a squared and the b squared. Add them together, you get c squared, and the square root of that is going to give you the answer. Okay? Here, once again, you've got two legs. So a squared plus b squared is going to be 64 plus 64 is 128. So the square root of 128 is going to give you this measure here. That's 11.3. You know what? I'm assuming... Yeah, no, that's well, yeah. So I use the square root function. I'm thinking of something else. Okay, so sorry about that. Here you've got two known. One of them is the hypotenuse, which means there's going to be a subtraction happening here because a squared plus b squared equals c squared, which means c squared minus b squared will tell you what a squared is. So 841 minus 441 is 400. So this leg is going to be the square root of 400, which is 20. Once again, here you've got a leg and the hypotenuse, so you're going to take c squared minus b squared to give you a squared. So 100 minus 25 is 75. So this length has to be the square root of 75, which is going to be somewhere between 8 and 9, since 8 squared is 64 and 9 squared is 81. So when you actually do the calculator function, square root of 75, 8.66, you may have rounded that up to 8.7. Here are two legs. A squared plus b squared is going to equal to c squared. Well, 36 and 64 make 100. What's the square root of 100? This has to be 10. And here you've got a leg and the hypotenuse. So 20 squared minus 10 squared will give you this. 400 minus 100 is 300. Square root of 300 is about 17.3. So now with 7, 8, and 9, these are all examples of situations that occur in real life. You know, real life situations where you would have to find the length or some distance using Pythagorean theorem. So find the diagonal of a television screen that is 30 inches by 35 inches. Now here's something kind of interesting. You know when you go to the store and you buy a television and it says it's a 46-inch television screen or a 60-inch television screen, they are actually referring to this diagonal, which is the hypotenuse of the right triangle created when you create that diagonal across from here to here. So kind of interesting that this would be a 46-inch television. I guess that's easier than saying it's a 30 by 30. Where are you? There you go. rather than saying a 30 by 35 television. It's a 46-inch television. Okay, so the 30 by 35 then become the dimensions here. I guess maybe I'll write this in. This might be the 30, this might be the 35, so 900 plus 1,225 is 2125, so that ends up being, what? You're not gonna, why would I lock it? It's ridiculous. Oh, and we didn't even have to show that? Well, I'm not gonna bother. So we've got the answers up here. A 9-meter ladder is 1 meter from the base of a building. Okay, so let's take a look at what that would be. Here's my lovely building. There's my 9-meter ladder, which represents a hypotenuse, right? Since the building is perpendicular to the ground, and the distance it is from the ground is 1 meter. So you're going to take this 9 squared minus 1 squared is going to give you 8 squared. Wait, what? No, it's not. 9 squared is 81. 1 squared is 1, so it's going to give you 80. So the square root of 80 is going to be our answer for the how high up the building that goes. And it almost goes up to 9 feet, but it's 8.94 or 8.9 meters. Meters, not feet. And then the last one, Sam drove 8 miles south and 5 miles west. All right, so if we take this as, like city streets, going south and then west, that forms a right angle, right? And so the distance from where he started to where he ended up is the hypotenuse of a right triangle. So going 8 miles this way, or is it blocks? Miles, that's 64 plus 5 miles is 25. Add those together, you get 89, and then the square root of 89 is going to be a little bit more than 9, less than 10, 9.43 miles. Okay, so we've been doing a lot of Pythagorean theorem. I just highly recommend you always copy down the theorem and then plug in the numbers as you go and work your way down with the help of your calculator. That represents half the test. The other half of the test is going to go back to talking about rational or irrational numbers. And I didn't give you any practice problems from this, but I did recommend that you look at the M&Ms for real numbers, because the real number system includes all rational numbers and all irrational numbers. So a rational number is any number that can be written as a fraction with integers. So if we can take any of these numbers and write them as fractions that are integers, then they would be classified as a rational number. If not, then the number that is going to be represented will end up being some decimal number that keeps going on and on and on forever with no repeating pattern. So the number 2, the fact that that is a terminating decimal, right? That would be 2.0. That's another indication that this is a rational number. But to prove it, we might say, okay, but it can be written as a fraction as 2 over 1. The square root of 5, I know that that's between 2 and 3 on the number line, because the square root of 4 is 2 and the square root of 9 is 3. But what exactly is it? So if I went to my calculator, I said, all right, let's find out what the square root of 5 is. There you go. There's that those decimal numbers that keep going on forever with no repeating patterns. So this is an example of an irrational number, and it cannot be represented as a fraction. 0.3 repeated. Rational or irrational? Well, the fact that it's a repeating decimal makes it fall under the category of a rational number. Remember, the irrational numbers have no repeating pattern to them. But 0.3 repeated does have a repeating pattern. It's 0.333. It's the 3 that repeats, right? And if we were going to write that as a fraction, I'm not sure if you remember this in our lesson, but if we said that x was equal to 0.333 forever, and then 10x's was equal to 3.333 going on forever, then when you subtract this from that, 0.3 repeated from 3.3 repeated, you get an answer of 3. And 1x taken away from 10x's is 9x's. So 9x's is equal to 3, and when you divide each side by 3, you get x is equal to 3/9 or 1/3. So once again, we're proving It's rational because we can show that it can be represented as a fraction with integers in the numerator and denominator. The square root of 16, well, that's a perfect square, right? So 16, the square root of it is 4. And since 4 can be written as a fraction of 4 over 1, then this qualifies as a rational number. No. Yes. Okay. And now this one's a tricky one. The square root of -5, remember the definition of a square root. The square root is any number that you multiply times itself to give you this number for an answer. So what would you multiply times itself to give you -5? I mean, you can't. Anytime you multiply a positive times a positive, you get a positive answer, and a negative times a negative, you get a negative, or you get a positive answer as well. I'm sorry, don't let me confuse you. I'm a little tired here. Yeah, negative times a negative gives you a positive answer. So there's no square root that would ever work here. That's not a real number. You cannot classify it as rational or irrational. Remember, all of these are real numbers. They exist on the real number line. We can work with these numbers. They all have a home. They all have an order. This does not work at all for the real number system. So if you ever see something like that and your choice is rational or irrational, you're going to say the answer is neither. All right, so you've got this weekend to take this test. Take your time with it. I have confidence that those of you that have been doing this work all along, you're going to do just fine on it. You might even get all A's on it. Maybe there's a tricky question in there, but I wasn't trying to create any tricky situations. It was you either know it or you don't, and you've got your calculator and you got your notes to help you along the way. So do your best. Take your time. No simple mistakes. Make sure that you double check your answers before you submit, and you will do a great job. All right, thanks. Talk to you soon. I'll get started on a Monday lesson anytime now. All right, bye.
Hey, feeling good.